Good morning. I'm going to give you a quick run through of what's in your book, starting on page 284. So that's where I'm going to start with this. Let me see if I can get this down a little bit. And it's called Calibrating Instruments. And the first thing it'll say is instruments such as multimeters, gauges, and thermometers discover the internal conditions of the system. They must be reliable. Be looking for that on your test Friday. All right? So before you use them, they must be checked on a periodic basis. All right? They may not stay in calibration due to moisture and vibration. So, listen to this. There is no substitute for good common sense, careful use, and proper storage. Good common sense, does anybody know what that is? That's not that common. But as a technician, we need that to be common for you. Now, calibration. This is on your term sheet this week. It says, means changing the output or reading to correspond to a correct reading. So there you go. It says usually analogs are the most calibratable, but the ones that are digital are usually not calibrated too much. Temperature sensing devices, like thermometers, how do you know that they're working right? Well, for HVAC, they're usually in a range of 40 degrees to 150, and as high as 220. Okay? Now, electronic thermometers, we have digital and pocket thermometers that look like this in your book. So you can see where I'm at. How do you calibrate them? Well, there's 3 reference points you use to calibrate a thermometer. The first one is ice and water, 32 degrees, body temperature about 98.6, and boiling water in normal atmospheric standard conditions, 212. All right? And remember, when you're checking water with ice in it, you need to make sure that the water's pure and you don't put salt and things in it which can manipulate it. Okay? If it's not pure, like salt and sugars become in it, you'll change the freezing point. All right? Do not cover the ice completely with water or it will float and will be warmer than the bottom of the mixture. Okay? And it's the same thing when you're checking boiling water. You put the thermometer in the pot. Don't let it touch the bottom of the pot. The hot metal, keep it suspended in the water. Okay, so in your book, there's your 3 reference points. And right here, in your book, you can see what I got highlighted there. That's about the temperatures and all. Alright. Next page it says, if we go to 287, let's take a look at that. Page 288, okay? Pressure test instruments register pressures above and below atmospheric pressure. The PT relationship of the gauge readings taken from a cylinder of refrigerant can be compared in the following manner. Check both gauges to see they read 0 psig. It's impossible to determine correct gauge reading if it's not set to 0 at the beginning. Then you take an old refrigerant tank or recovery tank. All right. Let's see. If the cylinder pressure is okay, so what they're saying is basically what you do is you put your pressure gauge on the tank. Then you take a thermometer reading of the tank at room temperature. And because you know what refrigerant it is, if you look at your PT chart, it should line up. If not, you may have to change, open your gauge, put the little screw, turn it, and check it. Now, I will tell you this. On My Course Connection, MCC, you have videos that tell you how to do this. So you should be watching that on My Course Connection. Okay? That's on My Course Connection. Electrical test instruments on page 289 right here. And that says, these are not easy to calibrate. and may not be, and some of them are not even able to be checked for accuracy. Now, your most common one is your volt ohm meter. It can be checked with resistors. If you know the resistor of resistances, like resistors, you can check it. I will tell you this. When you come back to the lab, we will have resistors, a whole pile of them for you to do. And I have a lab workout sheet for you to do where you have to look at the colors on the bands, the colored bands on a resistor, and you have to write down the resistor or the resistance you have, and then check it with your multimeter. You also have a lab worksheet you'll have to do where 3 different ways you are taught to calibrate your gauges. Next page it says, check ohms and resistance using Ohm's law. Now, electronic leak detectors on page 291. That's where we at in your book. Electronic leak detectors can detect rates as low as 1/4 ounce per year. Pretty small, isn't it? The detector samples the air. If the air contains refrigerant, the detector either sounds an alarm or lights the end probe. Some units may have a pump to pull a sample across the element, and some have the sensing element located in the head. Some electronic leak detectors can be adjusted to compensate for background refrigerant. All right. Never blow refrigerant straight into the sensor. That's not good for it. Never spray pure refrigerant straight into it, okay? And they even give you a picture right there to show you right and wrong leak detection right there. See that? So there's some more for you to read in your book. Now we're to the last page. Flue gas analysis. Pretty short course this week. This course is actually built around a lot of lab work, which you will be doing. Flue gas analysis instruments analyze products of combustion from fossil fuel burning equipment such as oil and gas to determine the combustion efficiency. All right, flue gas instruments are expensive, precise devices that deserve special care. Now, the thermometers they use usually measure temperatures up to 1,000 degrees Fahrenheit. And I will tell you this, with the flue gas analysis equipment, if you have a combustion leak detector or anything like that, they're not going to let you calibrate it. Why not? Because you have no business opening up those kind of tools and fooling with the settings. You have to send them in if they're not right to get them repaired by a manufacturer or someone knows what they're doing. General maintenance is basically this. Check your batteries and your power supplies and make sure they work. All right? Instruments you use extend your senses. Therefore, they must be maintained. Airplane pilots sometimes have a malady called vertigo. They become dizzy and lose their orientation and relationship with the horizon. Suppose the pilot were in a storm and being tossed around, even upside down. The pilot can be upside down and have a sensation that he's right side up and climbing. Sounds like somebody last Saturday night. The plane may be diving towards the earth while the pilot thinks it's climbing. Instruments have to be believable and read. So you can be lost, they saying, and you have to be instrument rated. Pay attention to your instruments, okay? I appreciate everybody who went over the thermostat wiring diagram video I did. It's very important that you watch those wiring diagrams. But that's everything in that chapter right there. We just did a quick review. Make sure you do your study guides and make sure you do your term sheets because all of that's a part of this lesson.